Hello everyone, welcome back. In the last video we discussed vector properties. Now we're going to discuss vector products. Now because vectors are more complicated mathematical objects, we can define vector products a little bit more in complicated ways. So we've got multiple vector products. There are many different types of vector products that we can have, but there are two that will be important for our uses. One will be called the dot product and the other will be called the cross product. Now there are one thing that I want to cover before we start. We talked about unit vectors in the last video, but essentially in order to make a unit vector, we make a unit vector u by taking a vector a and dividing it by its magnitude. So if I want a unit vector in the direction of a, I can make that unit vector by taking the vector and dividing it by its magnitude, and we make sure that its unit is 1, its magnitude is 1. All right, anyways, off of that tangent, we can define the vector product, or the dot product, given a and b are n-dimensional vectors. Then we have a is equal to a sub 1 all the way to a sub n, and b is equal to b sub 1 all the way to b sub n. Then the dot product a dot b is equal to the sum over I times of a sub I times b sub I. So basically what this means is if I have a vector, if I want a sub 1, a sub 2, a sub 3, and I'm dotting that with b sub 1, b sub 2, b sub 3, then I get a sub 1, b sub 1, plus a sub 2, b sub 2, plus a sub 3, b sub 3. So that's basically the vector product for 3 dimensions, and then obviously if it's 2 dimensions, then we only take that bit. All right, let's try an example. So compute the dot product of a and b such that a is equal to 156 and b is equal to 524. So what we do is we just multiply all of the components. We take them horizontally. We multiply all of these together, and then we add them. So we add them. So we get 1 times 5 plus 5 times 2 plus 6 times 4, which is 5 plus 10 plus 24, which is equal to 39. All right, now we can define the dot product in another way as well. If I have a vector a and I have a vector b, and I know this angle theta between them, and I know these magnitudes, I can take a dot b is equal to the magnitude of a times the magnitude of b times the cosine of the angle between the vectors. So why don't we try an example with this? We will find the angle between a and b. So for this, we kind of need a corollary of the definition we just found, which was that a times b times cos theta is equal to a dot b. So thus, we can write cosine theta is equal to a, no, that's wrong. We get cosine theta is equal to a dot b over a times b. Okay, so if I find the angle between a and b such that a is equal to 2, 2, negative 1, and b is equal to 5, negative 3, 2, then a dot b is going to be equal to 10 minus 6 minus 2, which is equal to 2. Now I need to find the lengths of all these. I use the Pythagorean theorem. I get a magnitude is equal to 3. So I get 4 plus 1 is 9, square root is 3. And then here I get, for b, 25 plus 9 plus 4 is equal to 38. Take the square root of that, we get root 38. So now we get the cosine of theta is equal to a dot b over a times b, which is equal to 2 over 3 root 38. So now I just use an inverse trigonometric function. You can solve this numerically with your calculator. It's not a particularly pretty angle, but anyways, we get that theta is equal to the inverse cosine of 2 over 3 root 38. All right, so that's all we have for the dot product. We'll be using that fairly extensively in future videos and multivariable calculus, but that's how the dot product works. The next video, we'll be talking about the cross product, also known as the vector product, and we will be discussing that. Just a note, we call the dot product sometimes the scalar product because it produces a scalar, and then we call the cross product the vector product since it produces a vector. Thanks for watching. We'll see you next time.